Mythical Man-Month. Now we skipped chapter 4 because you were all kind of tired and I didn't want to rush through. In chapter 4, Brooks talks about the need for conceptual unity in software design. This tends not to be a problem on small projects. When you do your own programming project, there's conceptual unity because you're the only one working on it. Or maybe there's 2 of you or 3 of you. But I'll tell you, once you get to 3 of you, you will find you have disagreements. Or not necessarily the same model in mind for what you're working on. Brooks makes the argument in this chapter for the need for a chief architect. Someone who has both the responsibility and ultimately the final word in the conceptual models that underpin the software. Why do you think, I mean, based on your readings and your own common sense, why do you think conceptual unity is important? Yeah?
I just remember when I was working on labs that I'd always have to go ask the TAs really specific questions like what a function would or would not do. And if those were just all made clear at the start, then no one would ask the TA questions.
That's actually a very good point. It's like, okay, what is stuff actually supposed to do? Other thoughts? Particularly if you got personal experience, yeah.
I liked, I know the book it talked about this. It talked about some, I think, castle or church that took a really long time to build. And they said the most impressive part was that the architects kept with the same themes instead of trying to just do their own thing, which I've definitely seen in software. Where
Oh, yeah.
You see someone just break out from the mold and then you have to go fix their stuff later.
How many worked on projects where it's quite clear that there was no central architecture or chief architect, and you have this mismatch of design approaches and implementation? Anyone? Yeah. Yeah, I've seen that a lot. One of the key issues, and this is the theme of Brooks, one of the key issues in software development is communication. The time it takes to convey ideas. Part of the reason to have a chief architect and to have a software architecture is precisely to, as per the comment in the back, to make it easier for individual programmers to know what they should or should not be doing. I was the chief software architect at Pages. My core architecture was 3 large hand-drawn graph drawings that I worked on for several weeks. I kept refining until I was very happy that each one was at a level of completeness and abstraction that I thought captured what we were trying to do. One was a class diagram, object class diagram, almost prototypical, but one that really stretched across our implementation. One was a system block diagram that said, here are the different components of the system, here are the main communications that take place. One was a composition diagram of a document. Since this was a word processor, the core object was a document. It's like, here is how a document breaks down into its component objects. And here's their relationship to each other. I did this on large graph paper with colored pens. Like I said, I did multiple iterations of each of the 3. And when I was happy, initialed and dated it. Then I went down to Kinko's and got big color copies of them. And each time we'd hire a new engineer, I'd give her or him those 3 sheets and say, this is what we're building, and let me explain it to you. And we actually maintained, in my opinion, very good conceptual unity throughout Pages. And as a result, after we shipped 1.0, each of our subsequent releases came out very quickly. Because all the engineers, all of us engineers, knew what we were building, we knew how the components worked together, and when we had new features or aspects to implement, we would look at the architecture and say, how does this fit? And we'd quickly arrive at a solution, and I didn't have to hold hands as chief architect. They understood the architecture, they knew what to build. I would look through their code, and if there were things that I thought were sort of breaking the architecture, or at least stressing it some, I'd say, you know, what about this? And we'd either adjust the architecture or they'd adjust their solution. probably the thing I'm proudest of is that this was a design-oriented desktop publishing system. This was released in March of '94. In late '94, we had people saying, have you heard about this World Wide Web stuff with HTML and so on? And we started looking into it, and what the director of engineering and I attended a Web World conference in January of '95. In March of '95, we released a version of Pages that was a drag-and-drop WYSIWYG web page editor. It was literally years ahead of any sort of web page editor that would subsequently come out. You could pull stuff off a palette, drop it into place, push a button, and spit out the HTML and the graphics. We would probably all be millionaires, except this was in '95. No one knew what the World Wide Web was. Our company was running out of money. We went to venture capitalists, and they said, what's this web stuff? Isn't Microsoft just going to own all this? And we didn't have the money to port it. Remember, this was all running on Next Step. We didn't have the funds necessary, and we'd saturated the Next Step market. We didn't have the funds necessary to get it over to Windows. We finally closed our doors. A few of the engineers went off, did their own startup, and did a web page editing application that was maybe 20 to 30% of what we had in Pages. And 2 years later sold themselves to Netscape for $25 million. Sometimes the geek lottery is a matter of timing. If you're out there too soon, you may not survive long enough to cash in. Other thoughts on pro and con on the need for architectural unity and or the consequences of lacking it. Anyone have experiences they want to share? Yes?
When I first started working, I had very little experience, and I asked my manager, like, is it all right if I make this change? And he kind of blew me off and said, yeah, make that change. And I made it, and it sort of pervaded throughout the entire app. And later he decided he didn't want that change because I didn't know what I was doing. And I was not the main architect. It took days to undo the change that I made because it just clashed with everything else. And so it was really confusing for anyone to try to edit later because two different philosophies that were clashing. So nothing really makes sense to me.
Yep. And this again, what you're trying to do is make your job easier, to improve reliability, to make the whole development process work better. I've already mentioned that when I went into Eric on their Iridium network management software, one of the first things I asked, in fact, I actually did a survey. I can't remember if I mentioned this. I went around to, they had the development staff. Okay, here was my first clue there were problems here. They had, I think, 25 developers, and their total code base was 20,000 lines of code. And I thought, why do you have 25 people working on 20,000 lines of code? At Pages, we had 8 to 10 people working on 500,000 lines of code. And we all knew our way around. So that was sort of a first warning flag. It's like, this is clearly highly fragmented. People are looking at little tiny portions and doing. But the other story, which I'm sure I told you, was I said, where's the architecture? And they gave me 4 diagrams that were designs for 4 major subsystems. There was no architectural diagram that encompassed the 4 of them. And when I tried to fit those 4 together, they did not fit. This is one of the reasons they were having problems. You had people developing 4 different subsystems that had not been engineered to work with each other. They were each their own little separate island. And one of the first things I had to do was basically look at all this, come up with an overarching architecture, and then start the process of having them rework the subsystems so that they did actually all talk to each other.
Did it work?
It did. In fact, we were the, and I don't take credit for this. Same time I started doing architecture stuff, Bob Millar from Motorola showed up, and you'll hear me mention his name before again. To basically get their schedule back on track. And he held their feet to the fire on having an actual complete specification. And our deadline, I started in, I want to say July or August. The next drop for the next version, dot point pre-release, was due at the end of October. And Eric was the only division of all the subcontractors and the major contractor, Motorola. We were the only ones who delivered on time. Everyone else missed that deadline. But I credit Bob for that. I learned a lot from him. Okay. Talking about communication. Chapter 7, why did the Tower of Babel fail? They had a clear mission. They had manpower, materials, time, technology. Of course, the problem was communication, and because of that, organization. How many of you read steampunk stuff? I have a short story coming out in a Mormon steampunk anthology, March, that basically takes the Tower of Babel and Brother Jared's story and recasts it as steampunk. Anyway, so the point is that you can do a lot of stuff right, but if there are significant problems with communication and corresponding organization, it can be a drag on your project, or it can lead, I'm trying to make sure I'm not walking outside of the scope, the camera here. It can be a drag on your organization, or it can lead to outright failure. How many of you have had experiences with communication problems within a project you're working on? Anyone want to share experiences? Yes?
Yeah, I remember back when I was in the good old classic 340 CS class here. We had a good group, but I remember one day we showed up to work on the project and one of our guys wasn't there. It turned out he was out of town and we had no idea. Like there was just no communication between us, and so it caused us kind of a lot of setback. And we had to take on his part, and then we're like behind, maybe a professor. And so if he had just mentioned to us before, like, oh hey, I can't make it, or something like that, just lack of communication in general.
Yep. Other experiences? Yeah.
Something I just always see with communication projects is if you're not communicating well, you end up coming to a meeting and realizing that like two people have been working on the same thing for like the last week, and then one, or you might try to take the best of both, but in the end, one's broke. Somebody wasted their time.
It is wasted time. Yeah.
When I worked at the IT building, I was on a project called Informatica.
Mm-hmm.
I don't know if you've ever heard of that old. It's not old. It's still current software, but it's used to transferring lots of data between databases. And I was given a project by the architects to move data from one place to another in a certain fashion. And a couple of weeks into the project, I realized that what they had told me to do and what I had thought I was supposed to do were different. So I had to scrap that 2 weeks of effort and restart.
Yep.
My last job, for reasons beyond our control, we all had to use the same dev site, but we were working on different pages, and someone changed something. Someone was working on the routing but didn't tell us, and so I looked at my page and it was completely broken, and I was debugging it for a while, and then I'm like, I can't figure out why this is down, and the guy goes, oh, I kind of changed some stuff, I broke all of it. So yeah, it wasn't my error, but I spent a while debugging.
Anyone else? Yes.
So this kind of ties in the last section with this one is I had two bosses and one told me to do something one way, so I did it, and then I turned it in, and the other boss was the one who was like approving the pull request, and he denied it, and I had to redo it the way that he wanted, and then I submitted that pull request, and of course the first boss didn't like it, and so I had to sit there as they decided which was best.
Oh, yes, yes. Talk about lack of conceptual unity. It's like, no, we want you to do this two different ways. Yeah.
I had a couple experiences last semester on one of the classes I was taking where there was a student in our group, and he wanted to work ahead, and so he would just kind of make a design decision and just run with it and code a whole thing. And then we talked about it at our group meeting and be like, actually, we don't really want to do it that way. And then we have to ask him to either redo it ourselves. And I don't know, it kind of felt bad because he'd done all this work, and if he had just asked us before, it would have been a lot simpler.
How many of you have participated in distributed development projects where you have geographical separation between different teams? Okay. I have too. It's hard. It can be done. I've managed that, but it's hard. At Pages, my sister Deirdre was one of the software engineers, and partway through the project, her husband was assigned the XO at Pensacola Naval Air Station. So she moved to Florida for 2 years, Pensacola. But she kept working, and we partitioned her work so it was stuff that she could work on, and we actually flew her back to San Diego about once a month to interact with people. And of course, we're talking, this is the early 90s, so you really don't have much in the way of like video conferencing and stuff like that. At least we didn't. Anyway, and it worked, and she did great work, but during those 2 years, she said, I feel so out of touch with the rest of the team. I'm not interacting with anyone. I don't know what's going on. I only get bits and pieces. There are decisions made, and they have consequences for what I'm working on. I don't find out about them until after the fact. So it can be hard. This is not, there are a lot of organizations which are actually quite successful with distributed development, but it typically takes a high level of communication. Either that or a very, very well-partitioned architecture, where you can, in essence, give a chunk to someone and say, go work on this for a month. And they can truly work without having to have that daily feedback and find out what the problems are. Project work. He talks about a project workbook, which now we have all online. In fact, that's what your wiki is, basically. Now, this is my firmly held position. The project manager and the chief architect need to be two different people. I say that because for the first year and a half at Pages, I filled both roles. Until we closed on venture funding and hired a VP of engineering, I was both the project manager and the chief architect, and I struggled at doing either one well. There is an inherent conflict between the two roles. There's a famous story of a group of tourists. This is sort of what you have with the chief architect. Famous story of a group of tourists in Europe seeing various sites and so on, and they're taken to the workshop of this master carver who does these elaborate carved wooden doors. And they all quietly gather, and he's sitting there in front of the door, and he's doing this very delicate carving of these intricate shapes and so on. And after about 20 minutes, someone in the group, tourist group, finally gets at the nerve and clears her throat and says, "Excuse me, but how long does it take you to finish one of these doors?" And the artisan turns around with a stricken look on his face, and he says, "I never finish them. They come and take them away from me." That is what software is often like. And it's a project manager's job to come and take the software away from you. To basically say, we are cauterizing these areas of effort. You're not going to get to do that feature. You're going to have to wrap this up, get this ready to ship. We're going to defer these bugs. I know you really want to fix that bug, but we don't have time to fix it. It's not important enough to fix it before we ship. Most software ships with lots of bugs, by the way, guys. And large software products ship with hundreds, if not thousands, of bugs, because they're deemed not important enough to keep the product from shipping. Yeah?
So if you're working on like a government contract, they obviously have a really big spec of what they need you to do. How does that work with like, if you're falling behind, like, can you cut features from that?
Oh, well, you're talking about the government. Government software projects are not noted for being cost-effective or on time or on budget. They tend to be mandated for a number of reasons. They tend to be highly political. So they may or may not cut it. I mean, I have been fortunate. I've never actually had to work directly on government software projects. I have had a number of friends and colleagues who have. And their experiences are almost uniformly negative. For exactly that reason. you have this, oh, we have to have all these features and you have to follow this rigid methodology. It's like, and we need it done by now. It's like, okay, these three things cannot coexist with each other. Something has to give. And what you have is you have massive software failures. Case in point, the United States Air Force has 100 and something different accounting software packages, systems that it uses. They don't cooperate with each other. The Air Force cannot balance its books. So a number of years ago, they started a big software project to have a single central accounting system to balance all their books. It went on for several years, and they pulled the plug, having spent $1 billion and having nothing to show for it. And what was interesting was in a post-mortem analysis as to why it failed, one of the big factors is one that we've already touched upon, we're going to talk about more later, was the thermocline of truth. Mid-level managers felt that they were politically unable to pass bad news upwards. In other words, when they tried to say, look, this isn't working, or here's the problem, or we need this, they were told to shut up and keep working. As a result, the Air Force wasted several years and $1 billion and abandoned the entire project. Your tax dollars at work. One of the things that will require in your team organization is you designate one person as a chief architect, one as a project manager, and they have to be two different people. Okay, plan to throw one away. This is actually one of Brooks' most famous comments. He basically said, plan to throw one away because you will anyway. He's talking about, basically, this is a reflection of armor. You get partway through a project, and you realize you didn't really know the best way to do it. And you throw out what you're doing and say, we're going to start over because now we know how really to do it. Now, Brooks himself says a good iterative / incremental methodology can obviate a lot of this. But you'd be surprised how often this is still good advice. That when you're dealing with the orders of ignorance, you may truly get halfway through a software project and realize you had exactly the wrong solution. And you have to throw stuff out. Anyone who's had sort of experience of that, getting partway through a software project and suddenly realize you've got exactly the wrong approach and you have to restart? Yes?
We had to make a e-commerce pickup where someone could come up into the store and pick it up. And so the first time we were on a time crunch, because we had like a peak season coming up, and so we had to rush through and build this thing, and it works, and then afterwards, after that peak season, we're like, all right, done with that, we're going to take these we learned and then make something that actually
Yep. And this, by the way, is very much tied into the concept of technical debt. Technical debt is all the quick and dirty and ugly stuff you do to get to a 1.0 release that you want to clean up afterwards. Here's the problem is, you as developers may know we're incurring technical debt. We're making all these mistakes. We've got some really ugly stuff under the hood. But we'll be able to fix it after a 1.0 release. You get to 1.0 and managers say, okay, now do 2.0. It's like, well, we have to fix all this stuff. No, there's no time for that. You made it work, just make 2.0 work the same way. It's like, no, 2.0 literally will not work because we're going to 10 times the customer base. And we can't do this on this little foundation we've built. Other people have had experiences. Yes?
Silver.byu.edu was the first web program I've ever done. I was working for the BYU air conditioning shop, and they're basically like, hey, we need a website, we need to interface with all these SQL databases, and we need you to build it. So the first version I built of that. It was the jankiest thing ever. It was the ugliest thing. I didn't know how to format anything. I didn't know how to do any, so I got it on the page and I showed my boss. My boss is like, well, I mean, the data's there, but this sucks. So I just started again and did it all again. And version 2.0 is pretty good.
Yeah. Yeah.
We were building for a startup company, and we had a section where there was a bunch of results that filter on them. and the filter would just like filter down to what you wanted, and you click on one of the results, and you would do stuff with that result. But later on, we realized there wasn't really, because it was a startup, there wasn't any reason to have the filter, so they wanted us to take it out. The problem is once we took it out, that it would show you results even ones you didn't want, so when you clicked on it, it would still like process it like it was only a result that you wanted. And we're like, oh shoot, we have to redesign this whole thing. And so it just was a lot more work to take out the filter than we realized.
Yep. Anyone else want to? Okay, let's move on. Oops. Planning the organization for change. Now, he covers a number of topics in this chapter. Here's a very real, oh, yes.
Sorry, this is going back a little bit. But how does the idea of plan to throw the first one away jive with the second system effect? From what I understand,
That's actually an excellent question.
like the first one is full of technical debt, and then the second one is full of all the bad ideas they had from the first one. So it was like, should you just wait to do the plan to throw the first two away?
His caution against second system effect. Now, part of this throwing the first one away is that often the first one never goes into production. You get to a certain extent and you realize, you may get to a point of realizing, okay, we really need to rethink what we're doing, and we're going to start over again. But if you get to a 1.0 and then you're going to redo it, his second system effect is a warning, which is don't try to add too much more in when you redo it. In other words, try to keep your scope constrained, because otherwise the temptation is, oh, we have all these other features we now want to add in. It's like, no, take the first one and redo it so it's more solid, you have better conceptual unity, it's more stable, more reliable, better performance, and then do incremental addition of features. Now, he covers this issue in the chapter, and this is a very real issue. Most organizations do not have a technical track above, say, senior software engineer, unless it's chief architect. In other words, you have sort of entry-level engineers and senior software engineers, and then you've got like one position, chief architect, and maybe CTO above that. What too many organizations do is once you get to that senior software engineer level, your only promotion is to go into team management. A lot of us don't want to manage teams. Some of us aren't terribly good at it. And this is a very real issue you should raise in your interviews. Now, there's a lot of organizations that do have technical tracks. And these tend to be, excellent technical organizations. But if you're going into corporate work or something like that, you'll often find there's like 2 or 3 levels of technical track, and after that you have to go into management, and they want you to get an MBA, they want you to learn profit and loss, and so on. What often happens in those cases is sort of my path. It's like, I'm not going to do this, I'm going to go become a consultant. And you join a firm that's doing specifically development. You try to be a senior professional developer or mentor, something like that. But this is something to very much keep in mind in your interviews. Now, he also talks in this chapter about the issue of maintenance. As I've already mentioned here, 60% of the total money spent on a piece of software over its lifetime is done after its initial release. It's all maintenance. Adding features and fixing bugs. And surveys have shown it's about 2/3 adding features and about 1/3 fixing bugs. The problem, the challenge with this, if you're adding features, is who's adding the feature, because often when something gets to a 1.0 stage, particularly if you're talking about deployment within an organization, not necessarily talking about commercial products here, get within deployment of an organization, it's kind of like, well, it's running. Well, we have an entry-level programmer. We're going to have her or him add this list of features and fix these few bugs. There's a good chance that person does not know the architecture. And they are, as some of you have already cited, it's basically, okay, I've got to add this, I've got to figure out how to make this work. And what you have is this entropy, or rot, or decay, as far as the internal technical and organizational consistency of the software. You have people who are randomly assigned at different times to change features and or fix bugs, and they often do so by the fastest means possible. And you may not have the level of testing, regression testing, and other kind of testing that goes on. So you have production systems that become less stable and less reliable over time. Software rot. And they reach a point where it becomes harder and harder to fix it because anyone going in is not dealing with a cleanly architected, consistently developed thing. They're dealing with a hodgepodge of fixes, and it becomes increasingly fragile. I'm changing something over in this routine, and with unbeknownst to me, it's breaking something over here. That's using data over here in a way that I don't expect. Have any of you seen or had experiences with this as far as making modifications to existing systems? Spared that so far? There's a good chance you will run into this right off the bat because as entry-level developers, you're often put on existing systems. You're saying, okay, here's this system, make these changes to it, and you have to figure out how to do that without breaking the system. Okay, one of my favorite quotes. From Brooks, how does a project get to be a year late? One day at a time. The parallel comment is the one by, I think it's Robert Glass, which is, it is so very easy to lose a day on your schedule. It is almost impossible to make it up. We often do not appreciate, and we are talking about everywhere from top management down to the development level, how easily a day can slip on the work you're doing. It's like, well it's whoever it was who talked about your 340 project, and the guy just wasn't there. And suddenly it's like, oh, well, we just lost like 2 or 3 days or a week on this project. This person wasn't there, we didn't know he wasn't going to be there, he didn't do anything. You know, a few nights and weekends don't make that up as a rule. There's a certain incompressibility to software projects, and if stuff slips, it slips. When we talk in a week or two, whenever we talk about PERT and Gantt charts, I think that's scheduled in 2 weeks, which means it'll either be in 1 week or 3 weeks. One of the things you'll have to do is come up with a critical path for your projects. It basically means if anything on a critical path slips by the day, your whole deadline slips by day. Now, how many of you have been on a project and someone says, how far done is it? Someone says, oh, we're about 80% done. How many of you have experienced that? Okay, what does that even mean? Especially in light of Armor. What does it mean to say we're 80% done? You know, unless you've got, you know exactly what you're building, unless with Armor you're at the 0 level of ignorance, and you know exactly what you're building, you know exactly what you have to do, you don't know that you're 80% done. And this leads, this 90-90 rule is not original with me, but this has been around for decades in the software industry. That the first 90% of a project takes 90% of the schedule, and the last 10% takes the other 90% of the schedule. Oh, I can't tell you how often that happens. You get projects that are listed as being 80 to 90% done, and they stay there for months. There are a number of factors behind this. One is what Brooks said. He says you plan on spending half your time on testing. You may not budget it, but you will anyway. I've seen so many failed projects that get to, oh, we're getting close to being finished, and then it slips. And it slips for a year or a year and a half. Why? Because they really weren't done. They deferred all the difficult projects, they really hadn't done the testing, and that last 10% actually wasn't 10%. The last 10% was more like 50% of what they had to do. They only thought it was 10%. 3 weeks before deadline rule. This was something I thought that I had discovered in all my review of failed projects. I kept seeing this consistent pattern in these projects that were late or had failed, which was they had an original deadline, they'd get 3 weeks before it, and they would, at that point, it would slip, usually for 6 months. Everyone likes 6-month slips. And they would get to the new deadline, they'd get 3 weeks before it and slip. I thought this was some clever thing I knew. When I started teaching this class, I went back and reread Brooks, and he had it right there as usual. You know, from 40 years ago. Yeah, we found that usually projects slip 3 weeks before the deadline. Reason why is the thermocline of truth, which we'll talk about. I don't think that wasn't in this week's reading, so it's going to be one of the other Webster readings, which is the level at which people really know what's going on. The closer you get to the deadline, the thermocline keeps moving up towards upper management. And you get the syndrome where 3 weeks before shipping, finally, those underneath top management can't hide anymore how bad things are. They say, oh, by the way, we're going to have to slip. And in some cases, they didn't know. In other words, it kept slipping up. So, oh, there we go. Not being really bad. Thermocline of truth, which is one of the things. Not knowing the news is bad. We'll talk about metrics in a later lecture. Metrics, we'll have a whole lecture on metrics. But I just saw someone talking about this online. I don't know if it was Twitter, LinkedIn, or Facebook, but back to Jerry Weinberg, that which gets measured gets fudged. If you try to use metrics to manage a project, what it really means is that your programmers and or team leaders will fudge the metrics. Sometimes consciously, sometimes almost unconsciously. One of the classic stories is, you have a company that's trying to get a product shipped, so they decide to start awarding a bug bounty. Any tester who finds a bug, and then the developer fixes it, both of them get like, $50. So you know what happens? Developers introduce bugs, testers fix them, and they have the money. You can make nice money on the side code now. If your measure is lines of code, you will have developers churning out lines of code that aren't necessary, in fact, are counterproductive. Anyone who's had experiences along these lines of metrics that have been distorting? Okay, you will. Well, this slide's a little early, so we'll talk about that later. Why don't we go ahead and take a break now? Go use the restroom, come back, we'll start again in about 7 minutes. I assume you can all handle it. And we'll get through the rest of the stuff. And with good luck, we'll be done by about 3:30.